Welcome back, Geometry Scholars. Thank you so much for working so hard today for your substitute. I really appreciate it. I want to come back to a great report, so please do your very best. Let's get started right away on bell work. We're on bell work 32, letter A. It says calculate the perimeter of the kite JKLM. So with this kite, with properties of kites that we should know, we know it has two diagonals. One diagonal bisects the other, which results in two congruent triangles. So obviously, since this piece is 8 and this piece is 15, those two diagonals are not bisecting each other. So this piece is 10, that means this piece has to be 10, so these pieces are congruent to each other. Which means, therefore, that the congruent triangles would be MKLM and MKJM. Those are my two congruent triangles, okay? So keeping that in mind, we have therefore then, I'm going to erase all of that. We have corresponding parts. So this piece is congruent to this piece is congruent to that piece, and obviously they share the diagonal. That's their third side, okay? So that being said, we don't have to find 4 sides here. We just have to find 2, and then we double them. So first up, with a triangle, the kite, the diagonals are perpendicular. They form right angles. So we can use the Pythagorean Theorem to find the third side. So to find ML, I can do 8 squared plus 10 squared equals C squared. A squared plus B squared equals C squared. That's the Pythagorean Theorem. So 8 squared is 64. 10 squared is 100 equals C squared. The square root of 164 equals C squared. And I need the square root of 164 equals C. Okay, now we can simplify 164. Okay. 164 breaks up into the square root of 4 times the square root of 41. The square root of 4 is 2, so 2 square root of 41. So this side is 2 square root of 41, which means this side is 2 square root of 41 as well. Okay? And we're going to do the same thing. I will use green this time to find the other piece. Let's find LK. Again, we'll use A squared plus B squared equals C squared. So 10 squared plus 15 squared equals C squared. 100 plus 225 equals C squared. 325 equals C squared. So the square root of 325 equals C. Take the square root of both sides. And then this breaks up into the square root of 25 times the square root of 13. I see 325. I know it can be divided by 5, so I tried dividing it by 25, and sure enough, that worked. So that results in 5 square root of 13. Okay? So 5 square root of 13 is the length of this piece and this piece. And I found all these pieces because, again, it said to find the perimeter of the kite. And so the perimeter, I needed to know all of the outside pieces and add them up. So let me go ahead and do that. I have 2 square root of 41 plus 2 square root of 41, which is 4 square root of 41. And then I have 5 square root of 13 and 5 square root of 13, which is 10 square root of 13. And that's the perimeter of the kite. Moving on to letter B, explaining why the triangles are similar. So if triangles are similar, they have to have 2 things. Or I guess technically, if shapes are similar, they have to have 2 things. They have to have congruent angles, and their sides have to be proportional. We learned some similarity theorems back in lesson 11, 3, and 4, which is where this problem is from. So if you were stuck, you could look back at your Cornell notes from 11, 3, and 4. So first of all, I have two triangles. I have triangle DCG, and I have triangle ECF. Okay? So I notice, first of all, that they both share angle C. So angle C is congruent to angle C. And what property allows us to do that? Well, that's the reflexive property. So those two angles are congruent based off the reflexive property. Okay? I also can see that they both have a right angle. Angle G is congruent to angle F because they are right angles. Okay? So the reason we're allowed to say that these triangles are similar is because back in lesson 11, 3, and 4, we learned that if two angles of one are congruent to two angles of another, the triangles are similar because that means that that third angle also has to be congruent. Okay? So if one angle is 30 and 90 and the other is 30 and 90, well, then the leftover of each one has to be 60. So the reason we know they're congruent is because of the angle, triangle, similarity theorem. And two angles congruent, so automatically the third angle is congruent. We also can write that as shorthand as angle, triangle, similarity. Angle, triangle, similarity. Okay? So that's why they are similar. The angle, triangle, similarity theorem. They shared an angle, so that angle is congruent to itself, and then they both had a right angle. So by default, the third angle is also congruent. And then it said to solve for DE. So we're going to set up a proportion between these two triangles. I see the hypotenuse of the smaller triangle is 3.25, and the leg that we have is 1.25. Okay. The hypotenuse of the second triangle we don't know, but we can call it CE, okay, from CD. We only know part of it, we don't know the whole thing. So I'm going to call that CE. And the corresponding leg we know to be 5. Okay. So we're going to cross multiply. Extend that page a little bit more. And on the left, 5 times 3.25, I have 16.25. And on the right, I have 1.25 CE. And when I divide both sides by 125, I have that CE equals 13. Let's look back at the problem. Is that what it asked? No, it asked for DE. So I see that this whole thing right here is 13. But they only want this piece right here. So how do I find that piece? Well, hopefully you know, 13 minus 3.25. Take the 13, subtract the 3.25, and you are left with 9.75. So you have to use the proportion and then subtract it from 13, and there you go, 9.75. Okay, that's the length of DE. Next up, this is from our lesson we just learned last class. Use the given lengths to determine if AB is parallel to DE. So if they are parallel to each other, then the sides will be proportional. Okay? So if AB is parallel to DE, the sides BC and AC would be divided proportionally. Well, let's set it up as a proportion. 7 over 15 equals 6 over 15. Now, hopefully you can tell by looking at it, this is not going to be proportionate because they have the same denominator. But just for the sake of the exercise, let's go through the activity. 15 times 7 is 105, and 15 times 6 is 90. Okay? So, is 105 equal to 90? No, it's not. So the answer, therefore, would be no. Okay? And obviously no, because the sides are not proportional. And last problem. The perimeter of ABC is 128 miles. Find AX and AY. This problem is a little bit trickier. Okay? First of all, we have two missing sides. We have a, y, and ax that we do not know. But we do know the whole triangle is 128. So I'm going to add up the things that we do know. We know 32, we know 37, and we know 24. So if I add those up together, 32, 37, and 24 makes 93. Okay? So first of all, 193. So 128 minus 93 is 35. So these two pieces that are left over, ax and ay, have to add up to 35. So I'm going to assign one of them to be called x. Okay? I don't know how much that is, but it's an x value. So this one, therefore, is going to be 35 minus x. It's whatever is left over. And that's the only way that you can have two variables is when they're the same letter. Okay? So ax, we're going to call x. We don't know how much it is. But ay is 35. That's how much is left over total, minus whatever ax is. And now we can set this up as a proportion. Okay? So I'm going to do 32 over x, 32 over x is equal to 24 over 35 minus x. And now I'm going to cross multiply. We did a problem just like this last class now. The hardest part was figuring out it was 35 minus x. Now we're going to cross multiply. Okay? X times 24 is 24x. 32 times 35 minus x. 24x equals 32 times 35 is 1120, I believe. Let me double check. Yes, it is. And then 32 minus x is minus 32x. Sorry about that. I was really hoping I could press pause before it came on. But anyway. Okay, so 24x equals 1120 minus 32x. We're going to add 32x to both sides. Okay, so now we have 56x equals 1120. And then we divide both sides by 56. X equals 20. So let's go back up to our picture and figure out which one did we label as x. We labeled ax as x. See right here? We labeled ax with variable x. So ax is 20. So ay then is 35 minus 20. Ay is now 15. Okay? So not hard. It's simple algebraic problems thinking through. I had to use the perimeter to find what was left over. With the perimeter, I didn't just divide it in half. I said ax was variable x, and then ay was 35 minus that, and then I cross-multiplied and divided. You guys are more than capable of doing this. I have complete confidence in you. Again, please be on your best behavior, and I look forward to seeing you guys next class. Have a great day. Talk to you soon.